Hello everyone, welcome back to Knowledge Bytes. When you look at a cat, you instantly recognize it. You don't calculate colors, you don't measure shapes, you don't analyze pixels. Your brain simply knows it's a cat. But have you ever wondered how AI does this same thing? How does Face ID recognizes your face? How do self-driving cars identify pedestrians? How does medical AI detects diseases from the X-rays? The answer is a powerful deep learning architecture called Convolutional Neural Networks or CNN. Today we will learn how CNN helps AI see and understand the images. Let's get started. Before understanding the CNN, we must understand how computers see images. Humans sees objects, computer sees numbers. Every image is made up of tiny dots called pixels. Each pixel contains numerical values. For example, red 255, green 120, blue 80. Together these RGB values create colors. A small image contains thousands of pixels. A large image contains millions. So when an AI looks at a cat image, it does not see a cat. It sees a Gantt matrix of the numbers. The challenge is converting those numbers into meaningful information. That's where CNN helps. Now, you might ask, why can't we use the normal neural network? Let's consider a simple image. Suppose an image size is 100 by 100 pixels, that's 10,000 pixels. For a color image, 10,000 into 3 RGB values, that is which gives the 30,000 inputs. Now imagine connecting all those inputs to the neurons. The number of connections become enormous. This causes huge memory consumptions, slow training, more computation, overlifting problems. Traditional neural networks became inefficient for image processing. We need a smarter solution. That's why the CNN were created. What is CNN? CNN stands for Convolutional Neural Networks. It is neural network specifically designed for the image. Instead of analyzing every pixel independently, CNN look at for patterns. The workflow is simple: from image to feature detections, from feature detections to the pattern recognition, from pattern recognitions to the predictions. CNN learn visual information gradually. They first learn simple patterns, they combine them into the complex patterns, then finally recognize complete objects. This makes CNN extremely powerful for the computer vision. Understanding of convolution. So let's now learn the most important concepts in the CNN. Convolution, right? So think of convolution as a tiny scanner moving across an image. This scanner is called a filter or kernel. A common filter size is 3 by 3. A filter examines a small region of the image, then moves across the image step by step. It searches for the patterns such as edges, lines, textures, shapes. Instead of processing the entire image at once, CNN focuses on local information. This makes image processing far more efficient. This simple idea becomes the foundation of modern computer vision. What are the filters? So filters are pattern detectors. Different filters learn different things. One filter may detect vertical edges, another may detect horizontal edges, another may detect the textures, or another may detect the shapes. Imagine several experts looking at the same image. Each expert focuses on something different, right? Together they built a complete understanding of the image. So the amazing part of this, so the filters are not manually programmed. CNN learn them automatically during the training. That's one of the reasons deep learning becomes more successful. Now let's get into the feature maps. So now if you look at this one, after feature map highlights were important patterns, right? If we see, look at this one. After a filter scans an image, it produces a feature map. A feature map highlights very important patterns actually. So let's see how learning process goes. First layer detects the edges. Second layer combines edges into the shapes. Third layer combines shapes into object parts, such as ears, like eyes and whiskers. So deeper layer combines these parts into the complete objects. For example, it's a cat. So this process is called hierarchical feature learning. CNN learns simple features first, then gradually learn complete concepts every bit. So very similar to human learn, right? So now let's understand pooling layer. After convolutional comes into pooling, pooling helps reduce complexity. Imagine a 4x4 feature map. Pooling reduces it to smaller representation. The most common the method is max pooling. The max pooling selects a largest value for region from the region. So now look at this one. This helps. So this helps. How it helps to CNN? It's reduce the memory usage. It reduce the computations and focus on the important features. Ignore unnecessary details. In simple words, pooling keeps important information and removes noise. This makes CNN faster and more efficient. Now let's understand the complete CNN architecture. Let's put everything together, right? The typical CNN pipelines look like this. So from input image, we are giving the input image and convolutions, and then ReLU activation, and from the ReLU to the pooling, and pooling to the convolution, and from the pooling, and then fully connected layers, and then finally it will be predictions. So convolution finds features, right? So ReLU introduces the non-linearity, and pooling reduces the complexity. The fully connected layer makes the final decisions. For example, the final we got that cat is 95%, for example, the dog is 3% and the rabbit is 2%. The highest probability becomes the predictions. This entire process often happens in the just milliseconds. Look at the real world example. CNN power many technologies we use every day. So, self-driving cars example. CNN detects roads, vehicles, traffic signals and predictions, right? The face recognition systems where we use daily, right? Used in the smartphones and security systems and attendance resolution solutions, etc., right? Medical imaging. So CNN helps doctors identify tumors, fractures and diseases. Security cameras detect suspicious activities and monitoring environment, right? OCR, optical character recognition, converting the images to the text, example including the document scanning and license plates. Manufacturing inspection, factories use CNN to identify products defects automatically. So that's where CNN has transformed industries across the world. So now let's understand how this topic, the CNN, helps in the AWS exam corner. So now, first question, which neural network architecture is primarily used for the image recognition? For example, the option A is RNN and CNN and LSTM and transformer. So far we didn't learn about these three options. The answer is CNN. CNN are specifically designed for the image processing and computer vision tasks. So this is a common AWS AI practitioner exam questions. Remember it. So from the key takeaways, let's quickly recap this today's learning. So CNN stands for Convolutional Neural Network. Images are collection of the pixels and numbers, and convolution uses filters to detect the patterns, and filters learns features automatically, right? And features maps highlight important patterns, and pooling reduces the complexity. CNN power modern computer the vision systems, right? So the next, most importantly, CNN enable machines to understand the images. So now comes to the final, and today we learn, right, how AI transform raw pixels to the meaningful objects. But from detecting the edges to the recognizing the cats, CNN form the foundation of computer vision. So in our next episode, we will move beyond the images and explore sequences. We will learn about the recurrent neural network, that is called the RNN, that is, and discover how AI understand text, speech and the time series data. So if you found this video helpful, please like the video, share it to the others, subscribe to the Knowledge Bytes, and don't forget to click on the bell icon. Thank you, and we'll see you in the next video.